and welcome back. I hope you had a great break. So today we're going to be looking at game theory again. We're going to be looking at it in relation to the exam question that we looked at in the last 12-mark question, just about game theory, for you to kind of think about what has been going wrong. So all of these examples are kind of from your work, so I just picked up some of yours and they kind of show like a little bit of a kind of story of progression as to things that might be wrong with them. Now, this is important. So this lesson we're going to play a game, and that game is going to be what's wrong with my matrix. But there is a little bit of a caveat that comes with that. So it's important for you to know that actually none of the matrix that I've seen are wrong. It's not that they're wrong. A matrix really can't be wrong. It's because it just shows outcomes, really. It's that the matrix doesn't line up with what you're trying to say, right? So the matrix that you have shown doesn't match the theory that you're talking about, or it doesn't answer the question, or it doesn't show correctly what it is that you're meant to show. It's not that it's wrong. It's not really possible for a game theory matrix to be wrong. So we're going to start off, like again, we're on the CRISP theme, so we're going to be looking at two. All of them have the same, so our firm B, so to speak, is going to be Christina Aguilera, and our firm B is going to be Christopher Pratt. So as we go along, you might want to like speed up and go through and be like, what's wrong with this, what's wrong with this? So the first thing that I want you to look at is this one right here, and I would like you to pause and have a go and tell me what is wrong with this matrix right here. So, if you think about what you're trying to say in the last question, there's actually several things wrong with this matrix. But we're going to kind of take it in order of like the things that are most annoying, kind of all the way through. And the thing that is most annoying here is that it doesn't actually tell the correct story. Right? It doesn't logically make sense with what we know for oligopolies, or even theoretically, or even logically without studying economics. So what is this matrix telling us? Well, it's telling us that if they both keep their prices high, then they get 10 and 10. That's potentially fine. It may or may not be correct. And then it's saying here that when Christina Aguilera decreases her price and Christopher Pratt keeps his price the same, that Christina Aguilera is going to see a decrease in her profits and Christopher Pratt is going to see an increase in his, which makes no sense, right? And then equally it says that here, when Christopher decreases his price, then his profit is going to go from 10 to 4, but Christina Aguilera, she's going to keep it the same. So her prices are going to be higher, and yet she's going to get more profits. So the firm that's decreased their price and the other firm's kept it the same, that firm who's decreased their price is going to see a reduction in their profits, more so than the firm that's kept it the same. Doesn't logically make sense. So these two need to be switched. Now I see this a lot, and the reason is because you get mixed up. So don't like be afraid when you're answering your questions to just underline in a different colour for that person, and then you can underline, so here, for the second. So then you know which one it corresponds to. So that brings us nicely to this one here, where I've switched them round, so it's now telling at least, you know, kind of the correct story. What is wrong with this one here, right? So on this one here, I'm going to put that their benefit is there. That's a benefit from price adjusting. What's wrong with this one here? Again, pause the video and see if you can guess what's wrong with this one here. So this one here is, this is the one that I really see the most common kind of mistake made by students. Lots of you made this mistake in your 12-mark question, so kind of listen up, I guess, a little bit here. So basically in this question here, well, let's just find our Nash equilibrium. Let's just find it. So for Christopher Pratt, we've got 10 to 8. So which one's higher? Obviously 10 is much higher than 8. So keep the same. 4 and 3, well 4 is higher than 3, so it's keep the same. So his dominant strategy is to keep the price the same. He has no incentive to decrease the price. And then if we look at Crisptina, we can see whether that's the same or whether it's different. Where is our Nash equilibrium? So we've got 10 and 8. Well, 10 is higher than 8. And then 4 and 3. Well, 4 is higher than 3. So therefore, her dominant strategy is also to keep it the same. So actually we have our Nash equilibrium. This is our tacit collusion position. It's our Nash equilibrium position. There is no incentive for these firms to break that same and same. There's no incentive for them to decrease price and enter into price competition. There's no need for them to do that. They won't do that. There's no way that they will enter into price competition. So again, it's not that that's wrong. There are situations that may well happen, but if you think about that question, it's not right in context of that question, because you're asked about what will happen if they decrease prices, and logically it's a homogeneous good. We can see that consumers, there will be some rational consumer behaviour and some consumers will switch. So here we can see that the reason why this is wrong is because there's no incentive to enter price competition. Right? So let's see what happens if we can sort that out. So have a pause here, this is our next one, and think about why this one might be wrong. Off you go. So here we can see that we do have an incentive to break, right? We do have an incentive for them to break that collusive kind of, or to break that same and same, whether it's tacit or collusive, because we've got 10 to 14. So there is an incentive for them to break. Now let's see if we can find our Nash equilibrium. So from A, Christopher, we've got 10 and 14. Well, 10 is higher than 14, so he will choose to decrease initially. And then Christina, she has a choice between 4 or 3. Well, she'll pick 4 because 4 is higher than 3. So actually, this here is our Nash equilibrium, right? Well, let's have a look if Christina makes any different decisions or whether there's anything else going on here. Well, she has a choice between same or decrease, 10 and 14. So she'll choose 14 over 10. And then when she does that, Christopher has a choice between 4 or 3. Well, 4 is higher than 3, so actually they won't move from that position either. So what we have here is we actually have 2 Nash equilibriums. Now remember the definition of a Nash equilibrium here. A Nash equilibrium is where one player, if they decide to move away from that position on the game theory matrix, they'll be made worse off. So both players are happy and satisfied with where they are, they won't move because they'll be made worse off from moving from that place. And we can see that's true for both of these. If Christopher decides to move from this, then he will go down to 10 and lose 4 units of profit, whatever, kind of numbers you want that to be. And if Christina moves, she goes from 4 to 3, and therefore she has lost 1 unit of kind of profit again. So she won't, neither of them will move, and that's equally true here. If Christina moves, she will go from 14 to 10, so she will lose 4 in that case. And for Christopher, 4 to 3, so he will lose 1 in that case. So there's 2 Nash equilibriums. So the reason why this is that there's no benefit for either one from this to actually decrease their prices to match, right? So there's no incentive to price match if they do move to, if one firm does move to decrease. This actually is an economic theory. It's a pretty outdated economic theory that's called Battle of the Sexes, if you want to have a look at that just in your own time. We never get tested on it, but just in case you're interested. So the reason why this is potentially wrong is because there's no incentive to kind of price match, so to speak. So for either of the firms, there's no incentive to price match. Once one firm has broken the collusion, there's no incentive for the other firm to match that and actually enter into a price war. They won't enter into a price war, they'll just move, right? Because a price war requires both of them to keep chipping away at their profits, if you think back to the kink demand curve. So, let's think about how we can solve that problem, and if you have this in your kind of exam, if this is what you did for your question, think about how we can solve that for the next question. And let's think about this here. What's wrong with this one here? Have a pause, have a go, think about it, off you go. So the first thing that we're going to do is see if we can find our Nash equilibrium. So we've got here, Christopher has between 10 and 4. Well, 10 and 14. 14 is much higher than 10, so he will choose to decrease if Christina keeps the same. And then if Christina chooses decrease, next time I'm going to choose something that is more easy to say, you know? So then 4 and 7, well 7 is higher than 4, so it's actually decrease here, right? So far, so good. And then for Christina, we've got 10 and 14, well 14 is higher than 10, and then we've got 4 and 7, and again 7 is higher than 4, so she will also choose to decrease, and they will end up here. Nash equilibrium. So this one is actually correct. So if you got that and you couldn't find anything wrong with it, well done. But the reason why I put that here is because I want you to think about why this one is correct compared to this one, right? So what is it that we can change here to make this one correct? Like, is there kind of a rule of thumb that we can think about to make sure that we're always getting that right? So, I mean, really the answer might be quite obvious for you, and that is this number here. You need to pick a number that's between these two numbers. So then the person who has a smaller amount of profit actually has the incentive to cheat and to move, well not to cheat, but to move and price match, the better way to say it. So they have that incentive to price match there. That's what you need to show. You need to show that there's an incentive to price match. So you need to show two things. You need to show that there's an incentive to cheat, but also that there's an incentive to price match as well. So I've got one kind of bonus one, and I want you to see if you can tell why this one is wrong as well. So this one is incorrect because, well, I mean, we're just going to very quickly kind of work out and see why this one is incorrect. So we've got here Christopher, 10 and 8, well 10 is higher than 8, so they will choose to keep prices the same. If Christina decides to keep hers the same, they will match that. And if Christina decides to decrease, they have 4 and 5, so they will choose to decrease. So they don't have a dominant strategy. They're not always keeping the same or always decreasing. Actually, what they decide to do is dependent on what the other person does. So let's have a look for Christina. She has a choice between 10 and 8, well obviously 10 is higher than 8, and she has the choice between 4 and 5, so she will choose 5. So again, she also has a mixed strategy. So once again, we have two Nash equilibriums. So that is here, because she will not want to move, and she will not want to move, and he will not want to move, and also here as well, for the same reason. So she will not want to, he will not want to move, and she will not want to move, right? So in this situation we have two Nash equilibrium, and I just want you to think about why we have that. So why does that exist? Why is that here? It's a pretty simple answer. I hope that you got it. It's because there's no incentive to cheat from the same, right? So we've got 10 to 8 here, and then we've got 10 to 8 here. So there isn't any incentive to cheat there. So because of that, there's two Nash equilibrium. So if we compare that to this one that we had before, there is the incentive to cheat here. So it goes from 10 to 14, 10 to 14. Whereas on this one here, it's 10 to 8, 10 to 8. So there's no incentive to cheat. So as we can see, this one here is the only one that was correct. These are all the ways that the game theory matrices that you did weren't showing exactly what you wanted them to show. So I hope that that was useful for you. I hope that you can go back and have a look at your answers and see where you went wrong. Have a great day, and I'll see you all soon. Bye.